What if the building blocks of life don't belong to Earth alone? Just days ago, scientists detected a molecule critical to life drifting through interstellar space. It's a reminder that the ingredients for life, meaning, and connection may be written into the universe itself. Today's conversation invites us to look up, outward, and inward, all at the same time. You're listening to Wild Connection, where every conversation is a journey into what it means to be part of this wild and complicated world. I'm your host, Dr. Jen, and I talk with scientists, authors, and changemakers about people, nature, and the surprising connections that tie us all together. Welcome back to Wild Connection, the podcast where we explore what connects people, other animals, and the planet to create a better life. From the soil beneath our feet to the stars above our heads, we are part of a story. Recently, astronomers made headlines by detecting a molecule essential to life floating in interstellar space. Not on a planet, not in an atmosphere, but between the stars. It's a discovery that challenges the idea that life's chemistry is rare or planet-bound, and it invites a bigger question. What does it mean to belong in a universe that was primed for life? In this episode of Wild Connection, I'm joined by Ersilia Vaudo, astrophysicist at the European Space Agency and author of The Story of Astrophysics in 5 Revolutions. Ersilia has a remarkable gift for making the cosmos feel intimate by weaving together the science of gravity, relativity, dark matter, and cosmic expansion with the human drive to understand where we come from and make meaning of our place in the universe. Ursula, welcome to the show. Thank you for being here.
It's a pleasure, a great pleasure.
I really enjoyed your book, The Story of Astrophysics in 5 Revolutions. And it really never occurred to me that astrophysics could be so accessible. And so, we often, before I get into the book, which I think everybody should read, we often ask people, on the show, what draws them to the field that they are in and how they got there. So would you mind sharing what led you to study astrophysics and then what prompted you and motivated you to write this book?
Yes, this is a very important question, and I'm always happy to answer because it goes back to my childhood. I grew up in the south of Italy, in a small town on the sea, and I already think that to give to children the opportunity to really be in contact with nature is the first experience of science. They are all explorers, the children, and is the moment when you are able really to enjoy nature in every form, to start asking questions. They don't fear to ask stupid questions. This is the beauty of that age. And is through this that you start to have the first sensitivity towards science. Science is really about this, asking questions, and sometimes don't trust all the answers. This was already a part of my life that I consider being very, very important in that my approach to science, and all of my life also this attitude toward questioning things. But what really made the difference, I have to say, in my childhood is that my mother, she was a teacher, chemistry and biology. And if you see the series lesson of chemistry, she was very much like the character. And she was very, very passionate. And for instance, just to give you an example, to encourage myself and my 2 brothers to approach science with a sense of familiarity, to understand that nature has many languages, and we should not fear this difference in languages. on the kitchen jar, she didn't write, I don't know, salt, sugar, or soda, but she was writing the chemical formula. And this was terrible for us, because I remember that once, instead of putting the sugar on the top, how you call it, the glaze on the
Yeah, yeah,
top,
yeah.
yeah, I was actually putting baking soda, because we were the same. And I remember that it was kind of a bake sale at school, and I don't want to know what happened to the poor person that bought my cake. Uh, but this was part of the attitude. For instance, also when we were reading the books from Agatha Christie, my mother was always reading with us and say, okay, let's see which kind of information we have, which kind of information we don't have, what she's trying to make us believe, why we should not believe it. So really the pleasure of the logic reasoning, and again, one of the most important thing is not be afraid of this scientific language. And I also say sometimes that having at home a mother that when we got to her asking, can you help with homework in mathematics, was not answering, ask your dad, was already, something very, very motivating. So, however, although at high school I had no problem with mathematics and science. I wanted to, I was very tormented. I was a teenager with many existential questions. And when the time came to decide what to do, I would have probably chosen philosophy or literature. I did a lot of English literature that I loved, but I was afraid that this would have kept me too much focused on myself, on my center of gravity. In a way, I really needed to an objective perspective. I needed this sense of feeling just to be a spark in a universe that didn't care about me, and this gave me a great sense of freedom, but also of empowerment. And I have to say that it was really one of the best choices, because it's studying physics and then astrophysics. But physics is really the only occasion we have to get out of our comfort zone of the experience, because our experience is the world of Newton, but the reality is much larger than this. And it gives a sense of belonging to this reality that contain us, but is out of reach. And this is really very much, inspiring.
I mean, you've just inspired me. I have to be honest, when I was younger, I didn't spend much time contemplating the universe or my place in it. I had most of the time my head down in the ground looking for things that were living and wanting to watch them. And that gave me the sense of stronger connection than just myself, and a way to be a part of that bigger thing that's out of reach. I can watch animals all day, but I can't embody them. I don't know what their experience is. I can only glimpse it in a certain kind of way. And I think for many people, I don't know, but astrophysics can feel really distant and difficult, and even hard to comprehend. The notion that we send things now into space, traveling 4 billion miles somewhere, like how, like I can't even conceive of that distance, right? It's just this very large number. But you made it in your book, The Story of Astrophysics in 5 Revolutions, feel really intimate. And I appreciate how you took the perspective that we're all the same, we're made from all the same stuff, and inviting people to move away from such an anthropocentric point of view and be more inclusive. And I know that also is part of your work at the European Space Agency, where you're now the special advisor on future talents and bringing people into the field. And so in reading your book, it really felt like you were asking people to connect with the universe as something more personal. And I'm wondering, how did that develop for you, and why do you think it's so important?
Yes, thank you for this question. First of all, let's start of this sense of we are part of the same, how can I say, of the same transformations. So let me just say a few things, a little bit explaining why this is so true. First of all, we have to say that the first nucleus of hydrogen, that has been the first letter in the alphabet of matter, the first nucleus were created in the first 3 minutes after the Big Bang. After they were done, everything comes from the first 3 minutes. So the nucleus of hydrogen in the bottle of water that we are drinking comes from the first 3 minutes. Then most of the material were created in the earth or stars, thanks to nuclear fusion, or in those explosions that, in a way, mark the end of a star, mark the death of a star. So, me, you, a sandwich, a club sandwich, the desk in our grandmother's room, we are all made of the same stuff, and essentially, let's say, stardust. So, of course, this leaves open, and this will be for my next life. I will do this open the question of at which point this stellar dust got consciousness. And this is really a fantastic mystery, and it's amazing to think that, I mean, this is the miracle in a way of being who we are. But still, it's really this sense of, first of all, of the miracle of what we are, the miracle of this amazing planet. I opened the book with this image of Earthrise when, for the first time, Apollo 8 crew saw the image of Earth rising on from the moon horizon, and this sense of looking back at us, this sense of the beauty, the blue of the oceans, the white of the clouds on the glaciers, the brown and green of the earth, and all this in a absolute dark eternal night, and where the atmosphere is all separates us from a suffocating void. So this sense of a privilege that for me is also this kind of because it's not easy to study physics, and because you have the wall of mathematics in it, is to say, do it. Science is the greatest adventure, brings you to places, and is not for few. The emotion that comes from the journey of science, and can be what you do, can be watching animals, which is another fantastic subject, can be anything related to this inquire, to this trying to use our brain to understand our, without an anthropocentric view, because we are part of the same destiny also, is what really motivates me. My girlfriend always joke with me, because I can call them in the middle of the afternoon, say, but have you understood how clever is the molecule of water, that instead of being linear is curved, which means that the ice, when it's frozen, is just floating on liquid water and can preserve the fishes, while if it was heavier in density, it would have killed all the fishes. So do you see how amazing this is? And this is an enthusiasm. I think it's everywhere you turn, every element of science can really bring you in uncharted places, and making questions and be curious is really what takes you there.
I was thinking, curiosity. Without curiosity, many of the revolutions that you write about in the book would never have happened. And that enthusiasm and that joy and the awe of the things that, when you sit and contemplate this properties of water, just the properties of water that you described, and the implications. It is fantastic, and to be excited about it, even after you've been studying something for a long time, I think is one of the hallmarks of what you called the adventure of science. And there's also practical parts. So, in conservation, we talk about tipping points, moments where there's a shift in our understanding, and that it leads to real change in how even societies can think and act. And in your book, The Story of Astrophysics in Five Revolutions, you talk about some of these major changes, these moments that changed everything. And I want to first go to Newton. So it's a little bit in order, but like many people, my understanding of gravity growing up started with the story of Newton. But he was dozing under an apple tree, and suddenly he had it all figured out. But but of course, as you tell the real story is far more complicated, and it's built on earlier discoveries and evolving ideas. So, in your view, what was the most revolutionary concept to emerge from that early work on gravity?
Okay, first of all, let's say that I call gravity His Majesty, because gravity for me is really, is the greatest designer, is what makes this perfect spherical bodies, celestial bodies, and it's a mystery itself. One of the mystery is why it's so weak with respect to the other three forces, and one explanation is that probably it gets diluted in other dimension, but this is probably not at this stage of the interview that I should start to talk about this difficult thing. But gravity gets on the stage, and the amazing intuition of Newton was to understand that behind a falling apple and behind the eternal orbits of planets around the star or a moon around the earth, there was the same hand, there was the same force. And actually this was a thought that was not so, he was studying, he was developing his equation. So if you have an acceleration, there should be a force. So he said, why cannot be the same force? And to understand this was revolutionary, because up to that time, apart from some work from Kepler, but we were convinced that the celestial world and the sublunar world, were terrestrial world, were completely different entities. Even the celestial world made of completely different, how can I say, fabric. And so to say, no, these are not two distant worlds, one that belongs to the gods and the other that belongs to us, but is the same force that makes all these movements, and actually everything is in a movement, and behind there is a hand of gravity, was really amazing. And the only difference, just for who is listening, between the falling apple and the orbit of a planet is that the apple, when the gravity acts, is at rest on the tree, and then it falls straight down, while a planet start to turn around the star, but actually would like to escape. So it's a balance between the willingness to escape and gravity that is pulled you down. This equilibrium is an orbit. So what is interesting, I also want to go to what you said at the beginning, these intuitions. We should not forget that these intuitions then take a long time before they're really accepted. So it's never something, the change takes time. To be counterintuitive is not just difficult because it's difficult to have counterintuitive idea, but also because you are risking to lose the consensus. You are risking things, and this also with Newton. Actually, the arrival of the theory theory of gravitation in Europe was essentially thanks to Victor Hugo, that was really marketing the Newton theory, while at the time it was essentially Descartes, the Cartesian, I don't know you say in English, theory that was the one that was in a way considered the most appropriate. So it takes time. The same for the other intuition. It's never something people say, yes, you're right. Why not this way? And but what is amazing also about Newton was a special character with many interesting stories is that actually he never clarified. So introduced gravity arrives, but he never clarified how bodies that are millions of kilometers apart can influence each other. He left this answer, the answer to the reader. And this is what actually Einstein picked up 200 years later.
Yeah, and that's what's so I want to come back to Einstein, but I wanted to kind of follow that thread about how people don't just go, oh yes, okay, you know you're right. If a belief is embedded deeply into the culture, it takes time for there to be enough of a push to new ideas. And I always think about I guess I think about Galileo. He always seemed to be in trouble for his ideas, so much so that he was persecuted relentlessly. And for centuries, prior to Einstein and prior, he challenged dominant worldviews and he faced strong opposition from the church, which was very powerful at that time. And one could argue even today. Do you see kind of modern parallels right now in the field of astrophysics where there's society or policy creating resistance to bold new ideas? Or do you think that because of the technological advances we have, it's easier to move the needle when new discoveries or new ideas or old ideas that grow and evolve come into play for our understanding?
First of all, let me say that Galileo was also the one that was heavily teasing Keplero, because Keplero was saying that tides are caused by the moon, and he was laughing at this, as he was thinking that Earth has a special system, internal system. So this is something interesting, that sometimes you have great ideas, but at the same time you don't accept the new ideas yourself. And this will happen also to Einstein. Einstein, when he will have his equation of general relativity, his equation were telling him, look, the universe is expanding. He said, no, impossible. So I just want to say is that what changes when you study physics and astrophysics is the relation with, this is impossible. Because you see that it takes time, but we have such a grasp on reality so limited that we cannot have the arrogance to say, this is impossible. It's not, it's well beyond what we can even imagine sometimes. And in the Five Revolution, in my book, I also talk about those moments where you don't believe to something, the scientist itself doesn't believe to himself. Now, coming back to a parallel with today. Today, in particular, okay, let's say that there are many very, very interesting mysteries still ongoing. If you think only 100 years ago, we were convinced that the Milky Way was the full universe. There was nothing apart. The universe was the Milky Way. Then Hubble in 1925 was a giant intellectually and physically, was very tall, but he was obsessed by a kind of cloud in the Milky Way and discovered that this cloud was actually a galaxy by itself, so Andromeda. And we become all of a sudden two in this universe. Today we know that there are about 200 billion galaxies with 200 billion stars, and these are all just what we can observe. But all we can observe that is made by atoms emits lights. So what we can observe thanks to the telescope that receive lights is only 5% of what is in the universe. The 95% of the rest of the universe, we know that is there because there are gravitational effects, but it's not there. It's not atoms as we know. It's not matter as we know. Is the dark part of the story. So a proportion is dark matter. A proportion is dark energy. A bigger proportion energy that is pushing the universe, accelerates the universe. And what I find interesting about this idea of this expanding universe is that in an imaginary future, when we will be so distant as galaxy one of each other, so distant that the lights from other galaxies will not be able to reach us. This means that there will be no way, even with the most powerful telescopes, to know that there are other galaxies in the universe but us. So we will go back to believe that Milky Way is the whole universe. So in a way, the mystery can also go back and make a turn and go back. So this is just to say that one of these mysteries is the dark matter. There are many attempts, many telescopes now trying to understand what could be. Another mystery is, it's not a mystery, but let's say another great ambition of cosmology, astrophysics now, is to be able to put together in one single theory, unified theories, the three forces which are weak nuclear, strong nuclear, and electromagnetism, together with gravity. But this is very, very difficult because gravity is a continuum, and to be able to unify, you have to able to quantify in quantistic, make quantistic the gravity.
Okay.
And to make quantistic the gravity, given that this, which means to do packets of gravity, is very, very intellectually, theoretically, is not so easy. So there are many theories, and these theories are in competition, and also sometimes they are not even wrong because you cannot prove these things. Like, for instance, one of the theory that I like very much, but there are others that don't agree, is the string theory. In the string theory, to be able to have this unification, you need to imagine a universe, our universe, with not 3 spatial dimensions, but maybe 11, maybe 25. So, which is a big leap in terms of this is impossible. At the same time, there is not just one universe, but probably 10 power 499 universe. And this will not really something you can demonstrate even with the most although there are experiments and things, but let's say it's not something you will be able to do easily or tomorrow. So what I'm saying is we are now entering in a moment where there are amazing things on the table. There are amazing also new elements. For instance, since few years, since the detection of the gravitational waves, it's like if we have acquired a new sense, a new way to understand the universe, which is not light, but is this kind of shivers on the space times that during the journey, if they find an object, they make a deformation, keep a memory of what they met during the journey. And so they bring information, very important information. Even before the light was born, we could have gravitational waves telling us what's happened billions of years ago. So there is there are new things coming on the table, and the beauty of those mysteries, to grasp.
It's enthralling. And when you were talking about 10 dimensions or 25 dimensions, and I thought, gosh, we even struggle to realize that birds can see in 4 dimensions. And, and so, I think that a lot of these things make one feel like, where is my place in all of this? And I'm wondering how those early people, Newton, Einstein, all of them would respond if they now got to see some of the things that we can see. And for me, it makes it even more incredible the advancements that they made with the tools that were available, right? And I think about this with Einstein. I mean, I think I understood this right, that he established the speed of light. Is that correct?
No, what happened is, okay, first of all, let me say that on the line of what you're saying, that both for Newton and Einstein, this revolution they were able to bring on the table were done only using mathematics and imagination. There was no technology involved.
Right.
Of course, then to prove these things, you needed to do to observe the eclipses of the sun and things. But the idea came only from their ability to think in an abstract way. And this is something that, in my view, should very much be cultivated. It's even not imagination. Imagination is something that today is saturated by all we see through internet, artificial intelligence. The abstract thinking is something different. It's really how you put things together, and these experiments that was doing in his head, Einstein, is really, it shows how much we can do just by crossing dots in an unusual way and come to different conclusions. I think this is okay. So he was not the one that discovered when he arrived. It was already clear from the end of the previous century that the speed of light was something very peculiar because it was independent from the observer. And this is very important. This is a very important thing that change everything, because in the word of Newton, and is our word, the word of Newton, if I am running on a tapis roulant that is going at the speed of 10 kilometers, and I am running in that direction at the speed of 5 kilometers, if our friend is observing us from the outside, he will see a total speed of 15 kilometers. Okay, so it means, or if our friend is with us on the tapis roulant, we see us running at the speed of 5 kilometers. What this means that speed is relative, means it depends from where is the observer. Okay,
Yeah.
and speed is equal to space divided time.
Mm-hmm.
So in the word of Newton, space is absolute, time is absolute, speed is relative. Okay.
Okay.
When it came out that the speed of light was independent from observation, this was experimentally also demonstrated, so was the same independently from any observator, the speed of light get a promotion. It becomes absolute. And to become absolute, it means that space and time get demoted, and they have to dance a tango all the time to make the speed of light equal to itself and finite and independent from the observer. So, and this is how space-time comes. They become an interconnected thing.
Okay. And they become relative.
And become relative. So speed becomes absolute, and they go down and become relative.
Okay. And so, when we think about our personal experiences in life, many of us feel that time stretches or contracts depending on our emotional state, or, like how some things seem to last forever, and some things just are gone in the blink of an eye. But from a physics perspective, how bendable is time in practice, right? So what does science tell us about the true nature of this relativity?
And this is really the big, how can I say, intuition, let's call it like that, or revolution of Einstein with general relativity. In very simple words, space-time comes from special relativity. Space and time are linked together to make the velocity. Now, imagine space-time as a trampoline, okay, like a rubber line, a trampoline, where if you have some cross, one side is space, one side is time. if on this trampoline I put a bowling ball, the elastic trampoline, the fabric will flex, will bend, which means that closer you are to the bowling ball and more the elastic will be stretched. But the elastic is on one side space, on one side time. So time stretches in proximity of a mass or in presence of energy and mass. This means that, and this is not impossible, but it's true and is now experimentally more than proven, is that times go slower if you are on a beach than if you are on the mountains in Aspen, or if you are on a plane, or if you are on the International Space Station. So time feel gravity because time becomes part of this fabric and bends in presence of gravity.
Well, I would say some people might think that time slows down on a plane depending on how far you're going.
Yeah. And who is your neighbor on the plane?
Okay. Yes. Speaking of personalities, one of the things I liked, and I know we're bumping up on almost finishing our time together, but one of the things I liked was how you weave together the sometimes kind of messy human side of science with the science. There in science, like any other profession, there are rivalries, there are egos, there are life-changing collaborations. So why did you think it was important to include that human element into the book and into the stories?
This, I think that, and the book has the 5 revolution, and there is a last chapter that is about all we don't know, and we hope to all the mysteries that are still ongoing. For instance, how the universe will end, or about string theory and so on. And the difference of this last chapter with the other 5 is that in the other 5 you have always a person behind, an idea, an intuition, and is actually, it makes much easier for the reader to connect with the person, to understand the kind of path it was going through to arrive to that moment. Just to give you an example, if I wanted to write really just as much simplification, something, a chapter on the Higgs boson, that is much later in time, is something that it belongs to the last decades. Although it has the name Higgs, but you see that actually is a cooperation. You don't have the person say, why don't we imagine this? So it becomes more and more difficult to have only one person behind an intuition. Is becoming much more a team effort and cooperation, international cooperation. So what could be a Newton sitting silently under an apple tree, it will be much more unlikely to happen those days where you have again many people involved in this kind of steps. But a lot is coming also from generative AI. And I think there will also be some contribution to physics. There are many things going on in some American university where the machine becomes also a scientist, but also an observer in a way. And I think this can, if used in the right way, can support scientists to make connection or to explore things that maybe were unexplored until then.
Yeah, I mean, it sounds like it's an exciting time. And at the same time, for me, it always comes back to I think about I didn't know that in the Milky Way there's more universes, right? But I remember the first time I saw the Milky Way and the way that it felt to see it. And later, when I was in South Africa, I saw the Southern Cross. And I'm not an astronomer. I don't spend time gazing, up in through telescopes. But I remember seeing the Southern Cross, and probably, meant something to me because there's a song called "The Southern Cross" by Crosby, Stills, and Nash. But these were moments where, especially when I was in South Africa, I mean, there was no light pollution, and it was like a whole nother world was there. It was unbelievable because I had never seen, the night sky like that. And so, these give a sense of awe and wonder that I also think many people feel with, some of the natural wonders of the terrestrial world. And so, do you think that these kind of experiences help people feel that sense of connection beyond things that we can understand?
Yeah, I really believe this. And by the way, I have an association that is called the Traveling Sky, where we bring to children that comes from very disadvantaged areas the possibility to do science with their hands, and at the end they to watch at the sky and see with the telescope the rings of Saturn. And this is one of the most transformative emotions for the children. The word desire comes from desidera, be far from the stars, from Latin. And I think we all have this tension to rejoining something and to be part of something larger than us, beyond us. So it's really within us, this kind of aspiration. One thing that you should remember when you look at these fantastic skies is that every every twinkling light is a moment of past. We have many moments of past in the same darkness, and this because light takes time to travel, but this is also a sense that we live in the same moment, the present. For instance, a friend close to us is sharing a present, but in that same image, we also have something that is no longer there. Like when we watch a sunset, the sun is no longer there since 8 minutes. And this is also is a way to see that there are angles, perspectives that you just want to know. Like, I don't know, that sound is a privilege of Earth and all the planets with an atmosphere, because sounds needs something to move. So if we have Beethoven is also thanks to the way our planet with this little atmosphere is done. If there is an explosion, if a star explodes, is mute, is silent. There is no sound, and these little things, particularly in children, really can get and activate a new curiosity, and I think is part of the motion of being human beings with a brain and a heart.
I think across time and cultures, humans have always looked to the stars, not only for navigation and scientific understanding, and sometimes climate for agriculture, but for meaning and for myth and for storytelling. And you've done such an amazing job with the story of astrophysics in 5 revolutions of bringing those stories to life for really anybody, and not even anyone with a background. Your writing really has a lot of lyricism and a poetry in it, and I love the personal stories of how your dad suggested the way to have a long life, right, is to
My granddad.
Oh, your granddad with an acorn in the pocket, and
Yeah.
was it a walk by the sea?
Yes.
Yes. And so thank you for sharing your passion, your perspective, and this wonderful journey through the universe.
Thank you for inviting me.
Listening to Ersilia Vaudo, I'm struck by how astrophysics does more than just explain the universe. It can change our perspective and sense of belonging. When we look out far enough, we're reminded just how small we really are, and yet how deeply connected we are to everything around us. That juxtaposition has been a thread that has moved through humanity for centuries, shaping how we make meaning, confront uncertainty, and decide how to live. In our next episode, that sense of perspective comes back down to earth through philosophy, something even Ersilia was intrigued by. I'll be joined by Dr. Massimo Pigliucci, where we turn to Stoicism to explore how humans have long grappled with uncertainty, impermanence, and what lies beyond our control. From the laws that govern the cosmos to the principles that guide a meaningful life, the question remains the same. How do we live better in a world far larger than ourselves? From the stars above to the choices we make each day, this is all part of the same search for understanding, for meaning, for resilience, and for our place in the vast web of existence. If you enjoyed this episode, please take a moment to like the podcast, follow, or share it with someone who might enjoy the conversation. You can listen on Apple, Spotify, or wherever you get your podcasts. To keep up with the new episodes, essays, and behind-the-scenes reflections, you can sign up for my newsletter at www.jenniferverdelin.com or visit my YouTube channel, Wow Connection TV. Thanks so much for listening, and stay curious.